See, we have already done this question earlier, but then I have written it because the wording is very important that you understand in this question. So, see, whenever I say A determines B or B determines C, if such a functional dependency is given, it is assumed that that particular functional dependency holds everywhere in the database. Everywhere you see A and B, if A determines B is there if as a functional dependency, it must hold true everywhere for every new insertion or whatever updation you are going to do, right? It is not that we generally have functional dependencies derived from the instances of the relations, right? So now just watch it. From the following instance of the relation schema or ABC, which means they are saying that there is a table with name R and attributes ABC, we can conclude that. So from this, what can you conclude? That is what they are asking, right? They are saying A functionally determines B, which means if you write the option A, they are saying this is true. Okay, so one thing is we can never conclude that a functional dependency is true based on the instance, isn't it? So whatever is the equation, as long as it is non-trivial, right? If it is trivial, it is fine, but then if it is non-trivial, right, non-trivial means there is no repetition, right? If it is non-trivial, then we can never be sure about any functional dependency unless we know the requirement analysis. By looking at the table, we should not say it, right? So we can never declare it. So A functionally determines B, we should not say it because we cannot conclude it, right? Okay, but then it might hold true for this particular instance, but I cannot apply this on the entire database, right? So for example, if I am saying A determines B, for a given value of A, there should be B value as unique. Now if there is any repetitions in A, B should be same. See this, there is repetitions in A, right? And what about B? It is same. There is repetitions in B, A, it is same. Therefore on this instance it is looking like it is right, but then I cannot say this for every instance of the this particular relation or on the entire database as a whole. So I can never say this particular thing, concluding this is not true, right? And if you look at the next one, A functionally determines B, right? So again this one is also a blunder, isn't it? I can never conclude this. It might hold true on this instance but not on the database. Now B does not functionally determine C. Yes, we can be sure about what doesn't hold, but we cannot be sure about what really holds, right? Therefore B determines C. Just check it, whether to check it or not. I want to check this. B determines C, whether it holds or not on this instance. So when will there be a violation? Whenever there are repetitions in the left hand side, which means if B repeats, I am interested in that. Yes, B is repeating here, right? What about C? C is not same, which means given a value of B as 1, you cannot come up with a unique value for C. Therefore clearly on these two tuples itself, it doesn't hold, right? Therefore B does not determine. I am sure about that. Okay, so B does not determine C. This is the option. Now what about this? A does not functionally determine B. So A does not functionally determine B. I am not able to rule it out. I am not able to rule it out because it is looking as if for this instance it is true. So from this instance I cannot derive that A does not determine B. So I cannot say that, right? So only option possible is this. So be careful with this. Okay, people think that from the relation table they derive the functional dependencies. That is where you might go wrong. From the functional dependencies, from the requirement analysis, we get functional dependencies, and we are going to apply functional dependencies as constraints on the DBMS, right? So it is not the other way around. Okay, fine.